We've been proving angle relationships, and we're going to now look at proving vertical angles, doing a proof with vertical angles. Now, if two lines intersect, the angles opposite each other are vertical angles, and they are congruent. So in this example right here, angle 1 and angle 3 are opposite each other. So are 2 and 4. 2 and 4 are also opposite each other. They also are vertical angles, and they're going to be congruent. You might also notice while we're here that 1 and 2 and 3 and 4 also constitute linear pair, and so do 2 and 3 and 1 and 4. But we're going to focus on vertical angles. Sorry to get a little off track there. So let's see what we have here in our proof. If angles 3 and 4 are vertical angles, and the measure of angle 3 is equal to 6x plus 2, and the measure of angle 4 is equal to 8x minus 14, find the measure of angle 3 and the measure of angle 4 and justify each step. And it's that justification of each step that gets us into the proof. Well, let's see. The measure of angle 3 is equal to the measure of angle 4, and that's based on the vertical angles theorem. They are equal to each other. They are congruent. And let's see what our next step is. Let me get over here where I can click in the right place. All right, so then if that's true, if measure of angle 3 is equal to the measure of angle 4 based on the vertical angle theorem, then 6x plus 2 equals 8x minus 14. And notice all we did was substitute what we had been given as the measure of angle 3 and the measure of angle 4. And next step, well, why don't we add 14 to both sides? We're trying to get the variable isolated so that we can solve for the variable. Once we solve for the variable, we can substitute it into each of those two equations. So we added 14 to both sides. That, of course, is the addition property. And then we end up with 6x plus 16, because 2 plus 14 is 16. Negative 14 plus 14 is 0. 6x plus 16 equals 8x. That's our old friend substitution. And now I think I may subtract 6x from both sides using the subtraction property. And then using substitution, I end up with 16 equals 2x. Guess what we're going to do next? We're going to use the division property and divide both sides of this equation by 2. Division property. And again, I got a feeling my old friend substitution's coming back up, and we're going to determine that 8 is equal to x, substitution property. Let's move ahead to the next slide, and let's actually find the measures of angles 3 and angle 4. So, the measure of angle 3 is equal to 6x plus 2. That's a given. I think I'm going to substitute 8 for x. Oh, I did. So the measure of angle 3 is equal to 6 times 8 plus 2, or 50, using substitution. And the measure of angle 4 is equal to the measure of angle 3. We've already stated that, the vertical angles theorem, and so therefore the measure of angle 4 is equal to 50, using our old friend substitution.